I see he hasn't got the carrot yet. Keep running. A surveyor is trying to make out a triangle. Rectangle, rectangle, rectangle. All right, so let's get some sort of rectangle. We're not sure if it's a rectangle. He's trying to make out a rectangle. See, that word tells me that these may or may not be right angles. It's got the sides, 13.3, 17.9. Well, let's make the long one 17, and this one 13.3. Oh, and he's worked out the diagonal too. Now, surveyors, for instance, are those guys who walk around with those like little tripod things and look in there, and you look over that other guy, and the other guy's standing there with the lollipop thing. That's surveyors. So they work out how flat the land is and whether or not the road needs to rise, that sort of thing. Just for instance. Okay, that's what's happening with surveyors. And so, this sort of maths is, inbuilt into their systems. So 22.3. The question is, is this a right angle? So this is the converse. So our job is to look at the longest side. 22.3 squared. Okay, don't have time for the molar 10. 22.3 squared equals 497.29. And the two short ones, okay, the two shorter sides squared equals 17.9 squared plus 13.3 squared equals 497.3. I do believe I'm going to call that a match. Yes, this forms a right angle. Now, for something like that's a patch of land that's being marked out, something like 0.1 centimetre, I think is acceptable. If this was some sort of small things and these were microns or making up some sort of computer chip, then we might have to be a bit more accurate. It'll be interesting to see what they say in the book. I'll let you check that. Check up that. Okay. One of the joys of teaching general maths is you get to work out fantastic words like, what is a truss? Okay. So on a roof, battens are the bits that go across the roof, and all the tiles go on top of the battens. And under them are the big pieces that hold up the roof. This is like a 3D version. This is like cut in half. But looking at the picture, I think, the only thing that's missing is this, and this is missing. And I guess they are the same. So let's put an X on there. Okay, so hopefully people have worked out that this is an isosceles triangle, because there's no right angle here, there's no right angle there, there's the right angles in the middle. And I want you to believe that this 16 gets split up into two equal parts. That's 8, that's 8, that's the same, and that's the same. This is the same as this is in both, and therefore they have to be the same. Congruent triangles is the maths theory behind it, but anyway, let's draw what we need. We need this triangle, x, 8, 3.2. This has been split exactly in half. C, A, B. Zooming along, same method as before. A squared plus B squared. So x squared happens to be one we're looking for. 3.2 squared plus 8 squared. Okay, x squared equals. We're just looking at using various items to keep this still. 3.2 squared plus 8 squared equals 74.24. So x, of course, equals the... Okay. Now, if we ever get an answer like this, or the calculator's being quite clever, we're going to go change it to a decimal. FD. Now, always remember to clearly show when I go from x squared to x. I get to about this point. I'm thinking, how many decimal points should I have? That's got 1, that's got none, so let's go to 1 decimal point. So 8.61 is going to be 8.6. Units now, meters. Okay.